Thank you for watching Knowledge Academy. So long time ago, when we start our pre-calc or calc course, we learn about topic in a single variable, right? We have a function maybe look like this, like a sine function, and this function you call it y is a function of x, right? It means we can plug different values of x and then we can produce value of y, right? So this is a single variable function, we call it, and that's a definite, the function side, and basically this is a graphical representation, how graphically function of single variable. When I say single, I also can say is one variable, right? It's pretty obvious that single means one, right? And if you want to know a little bit more, what we did, we just take different values of x, means I take this value of x, this value of x, this value of x, this value of x. These are the values of x, right? If you really want to be going, this is x-axis, and wherever this x-axis is cutting, like this point, this point, this point, this function is going to give me these values. Now what I'm drawing right now by circle. So bottom line is that you gave them x value, and the function actually gave you the y value, and y value is really nothing but the value at this point. So this is a y-axis, and the point at this point, this point, this point. These are basically the values you can get it from this function. Okay. Now, if you want to do graphically, function of several variables is going to be look like a little bit different, right? So if I want to talking about if the function is more than one variable, it's going to be look like pretty much this. I'm going to talk about the changing gears and talking about function of more than one variable. I'm not saying that two or three, more than one variable. So more than one variable means several variables. Several means 2, 3, 4, dot, 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 n number of variables. Depends on how much complication you need in your system. Depends on the variable, number of variable can increase. But it doesn't come for free. If you have one variable, it's easy to handle. If you have two, it's a little bit difficult. 3, much more difficult. 4 is very much complicated, and vice versa. It just keep increasing the complexity. And at some point, we are unable to handle them, so we use computer to handle those kind of problems and applications, right? Now, if I want to draw function of more than one variable, I'm going to do two things. I'm going to be drawing graphically, just like I draw here. I draw graphically and I write the function. So I'm going to be writing here. First, I'm going to be drawing graphically. So graphically is going to be look like pretty much same, right? And I have a function I can draw, just like that is one variable. We can say y equals to x. But if I want to draw, versus if I want to draw the function of several variables, it's going to be look like different. It's a 2D. So it's going to be look like this. And maybe this is one of the shape, right? So basically you just like you can see there's a big land, and on the land there's a little hill or there's a little mountain in the center. So this is like a 3D. Pretty much this is 3D, right? So if I want to do 3D, which axis is this? I'm going to be drawing the axis. I'm going to be drawing here. This axis is y usually. This axis is x usually, and this axis is z usually. So really this way I'm going to z, this way on this side I'm going to y, maybe x, depends on which coordinate system you are talking about. And this side or that side you can say is x. Okay, these are the three dimensions. Now here I wrote y is equal to fx. Here I'm going to be writing, on the other side I'm going to be writing here, function is x and y. There's a two variable function here, but I need to introduce the third variable. Right here I have two variables. One is here, one is here. Now here I have a group of variable here, and I have one variable representing the third variable. Okay, and how are we going to write here? We plug the values of x and y. Right, we plug the values of and y, and to obtain the value of z. Right, so we need to just get the two values of x and y so we can get the value of z. Now let's talk about domain. Let's talk about domain. What is a domain in this kind of situation? So if I want to do the domain, let me just draw here with blue line the domain. Let's say it's domain. So in domain, in this regard, I'm going to be making this space for domain. So here, domain is nothing but is the set values of x-axis. For this case, right? Domain, the set values of x-axis. So maybe you can say here the function is defined here. The function is defined here. So you are good here from here to there, right? But you don't know if the function is going up here or this function is going here. So you don't want to include, just like we did earlier. So probably you can say here, whatever the function is, maybe value here is x is 3, 2, and here is 3. So you're going to say function should go from 2 to 3, right? From 2 to 3, this is a domain. But you can also say that I want to include 2. I want to include 2 and 3. In this parenthesis, I do not include 2 and 3. I include in between 2 and 3. But if you want to include 2 and 3, you're going to change the parenthesis like this. And it means include the values, not in between, values as well. Okay, so this is this one. Here, the domain of this, the set values x and y. Not only x and y. Here is x, here is x and y. X and y means I need this value and I need that value. So think about it. What actually the domain for this function of several variable? It's a little bit complicated than what you thought. And when I say a little bit complicated, let me just draw here. I hope I can fit in this area. Think about it. In order to think about it, make sure you always use this method. If I give you any shape like this shape, you're taking a light bulb, right? Taking a light bulb on the top and turn on the light bulb. And light bulb turn on is gonna throw the light here, gonna throw the light here. It's gonna throw the light here. It's gonna throw the light back. So what's happened? This square is gonna block the light. This is square pretty much blocking the light. So you're gonna make the shade here or shadow, right? You can say shade or shadow pretty much. And this shadow is my domain, right? You turn on the light is gonna go here, it's gonna make it. So if let's suppose if you have a circular ball, if I'm asking what's the domain, it's not like a 2D ball, it's a spherical ball, it's like a sphere. Like you have a pumpkin shape. If I'm asking you, turn on the lights, you take the light bulb, turn on the light, what's happening in the bottom? You're gonna see round shape or oval shape or circular shape, whatever. This is my domain. This is my domain, right? So here the domain is pretty much, I would say that dot dot dot, that is my center. I'm gonna make, maybe I can make a center line from here, here, and I'm gonna say, you know what, dot 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 here. So really something like this is the one I'm just drawing. This is my domain. And what I'm going to do, I'm going to be just basically highlighting this to fill out with something. So I'm going to say this is my domain, the one I'm shadowing. Okay. Now, here the domain doesn't change, but here the domain could be changing. Here the domain could be changing. Why I'm saying the domain is changing? For example, I'm going to be going into this shape. Okay. In this shape, if you guys pay attention, I have a pretty much dome shape like this one, right? But what I'm doing, I'm taking a bunch of slices, like a bunch of knife or a butter knife or whatever you can call it. You can take this blue color knife and then poking inside. So you poke here, you poke one here, and you poke, just, you have three. So add all three what you have. The first one is going to cut from somewhere here, this guy. The second one is cutting from here. Third one is cutting from here. So if I'm asking you, give me the domain, give me the domain. You're going to asking me, where? I have to tell you, when I ask you domain, I have to tell you, give me domain and add value of z. So let's suppose this value of z is 5. So I'm going to say, hey, cut it at 5. It's like you go to z at 5 and then cut into this, and it says this is a domain. And you take only this portion, so it's going to be look like a tiny dome, like tiny dome. And when you turn on the light bulb, on the surface is going to be look like, you know, pretty much this shape. But if you cut it from the bottom, like here, then you're going to get a bigger piece, right? And if I turn on the light, it's going to be look like a bigger domain. Okay. And these shapes, so let me just do one more thing. These shapes, we call it like these lines, like this line. And if I cut it from another piece, like suppose it's here, another plane, so, and it's going to be cutting, and maybe it's cutting over here, right? This plane is going to cut here. I call these planes, or these curve, I'm going to call this curve, I'm going to call them level curve. Okay. And if you see from the top, sometime you forget about everything. All you see from the top is just like this. Right? You're gonna say this when z equals to 5, this when z equals to maybe 2, and here if you want to write here, you can say here z equals to 5 here, and then z equals to 1. Sorry, 2 here. If you want a z equals to 1, you want to make another one on the top here and then cut it in like that. Okay, you call it level curve, and this thing called contour. This thing called level curve, this thing called contour. If you want to look at the practical application, we can talk about that one in a minute, but let's go back and talk about function of several variable. Here, I'm going to add one more thing here real quick. If we have a function of several variable, what I'm going to do, I'm going to do a vertical line test. So if you want to write like this, z equals to fxy, and I want to know that if z is really depends on x and y only, yes or no. In order to answer this question, is that my z only depends on x and y, I have to do vertical line test. And what does that mean? Vertical line test means is if z is only depends on x and y, it means z has only one value for a respective pair of x and y. Okay, so let's suppose if I gave you value of z, I want a value of z. So if I say y x equals to 1, y equals to 2, if you plug it into the function, you only get one value, only one value of z should obtain. If it's not obtaining, it means z is not the function of x and y. It has some other things going on. For example, I have a sphere. I have a sphere. Sphere means 3D, right? It has a 3D, I can say 3D. The equation of 3D of this function is, of this sphere is x plus y squared plus z squared equals to 9. I want the z value or the function of z, so I rearrange this equation, and equation looks like this now. Z squared equals to 9 minus x squared plus y squared. Right? If I want to rid of this z squared, I'm going to say z equals to plus minus square root of 9 minus x squared minus y squared. But here's a problem. If I substitute x and y value, let's suppose 2 and 3. So I'm going to say z equals to plus minus 9 minus 2 squared minus 3 squared. And you got something, whatever, right? I'm going to say it's 4 minus 9, some value, and you get some answer. Okay. But when you get some answer, I'm not interested in answer too much. I'm worrying about these two. It means z equals to plus this and z equals to minus this. So it means vertical line test is failed. This is a vertical line test. And if I do this thing, it means z is not a function of x and y only. It has some other things too, which I don't know. And what's the implication of vertical line test? It means I'm going to take a vertical line like this line. And you gave me the value of 2 and 3, right? You gave me the value of 2 and 3. So I says 2 and 3, so I'm going to go, this is my x, this is my y. I'm going to go to 1, 2, 1, 2 here, and then 1, 2, 3. I'm going to go here, here. At this point, I'm going to make a line. So I'm going to draw a line here. I'm going to make a line like oops. If I make a line, draw a line here, but I pay attention on this line is this line cutting the sphere here and here, and that is a problem. It cutting two different points or two value of z. So this is plus value of z and this is minus value of z, and this is called vertical line test. This is called vertical line test. And it failed. It means I cannot do that. It's not a function. But if I take my curve, the one I just showed you in the previous slide, like this one, like domain, I take the slice and cutting this sphere into pieces, like I take this one here, 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 and cut. If I cut this guy from this equation, what do we call this curve? The curve I cut it, what do we call this curve? Level curve. So I cut this thing. How it's going to be look like? It's going to be look like this. The bottom part is gone. I cut it. So when I cut it, I'm going to go back again, do the vertical line test one more time. Vertical line. And this is hollow. It's from hollow inside, so there is no bottom surface. It's only cutting here. And I can say, yeah, z have only one value plus whatever. So I'm going to say z have only one value. Sorry, there should be no one here, by the way. It's just a negative value. So z have only one value, so z have only positive value here, whatever. I'm going to say is 5 maybe, for example, here. Right? And that is means z is a function of x and y. And somebody asking you what is the domain of this function, you're going to take the light bulb, turn on the light bulb, and how you're going to make that the domain, you're going to come down, right? The bottom you say is here to there. I'm going to make this. So that is a domain. That is a domain. So let's do some example, few things for the domain, and then go from there. Let's take a look another problem. Example. Function is giving this. And with plus. So what I'm going to do, I'm going to do most like a word, the verbal evaluation. When I say verbal evaluation, I'm going to say is, you know what, x should be bigger than equal to 0. Y should be bigger than equal to 0, because if you substitute x equals to -1, let's put -1, this is the arbitrary number, imaginary number. So it is basically invalid. My domain should be known or determined. If I make it -1, it's going to be indeterminate. So I can go up to 0. If I say 0, 0 is going to be square root 0 plus square root 0. The answer of the function will be 0. So I'm good with that. If I put 1 plus 1, I'm good with that. If I substitute 2 plus 2, I'm good with that. If I substitute 1 plus 2 for y value of 2, I'm also good with that. So I'm going to say my domain of this function, the domain. This is just like a rough work I did here, just to check my homework before I took the domain. So I'm going to say the domain of x and y, such that this is such that x equals to and bigger than 0, y is equal to or bigger than 0. If I can do this is my domain. If I want to sketch, this called sketch. So what I'm going to do, I'm going to draw this guy. I'm going to say this is x, this is my y. I can go up to 0, 0. So I'm fine with this line, right? And this is my domain. I can go more and more, whatever you like, go up and down. So this is my domain. This is my domain. This is my domain. I cannot draw here. I cannot draw here. I cannot draw here, because the reason is I am not able to. I'm not able to. I'm not able to, determine the domain on this side. Let's take a look another problem. I have again sketch the domain, and the function is giving something look like this. We all did the domain part for one variable function, so it's going to be pretty much same for this. It's just a two-dimensional one. Okay. In this case, whatever written inside the square root should not be 0, or so should not be less than 0. So I'm going to say is, in order to solve this, my condition should be x4 minus x squared minus y should be bigger than equal to 0. Because if you're writing something equal to 0, it's fine. The answer will be 0. But if you're writing something, everything is equal to bigger than 0, which is 1, you'll be fine. But if I write something like minus 1, oh, that's a problem. I cannot do that. Same thing, minus 2, I cannot do that. So it means this is my limit. Pretty much this is my limit, right? So if I want to rephrase this thing, right? If I want to rephrase, so I'm going to say, I'm going to take the y on the other side. Right? I can write like this, and y should be less than equal to 4 minus x squared. Right? So my domain in this case x and y values, y should be less than equal to 4 minus x squared. And if you say, hey, how does it even happen? So if you go here, if you take this guy and go here, write it like this: 4 minus x squared minus y squared. Y equals to less than 4 minus x squared. So if you type here, write like this: 4 minus x squared minus, substitute the value of minus 4 minus x squared. If you open it up, this one is going to be like this. And everything will be cancelling out, the answer will be 0, right? So you can add something, maybe you can write something else, maybe x, y equals to bigger than, you can write any other value too. This is just extreme, 0. So if you do a little bit bigger value, a little bit smaller value of this function, your answer will be maybe 1, maybe answer will be 2. But you don't allow to go to minus 1. So that's a caveat. Okay. So that is my domain, by the way. I want to draw and sketch this domain. Look like y equals to 4 minus x squared is kind of a parabola kind of thing, which is along y-axis. You cannot go more than 4 minus x squared, so you should be staying inside to this, so that your domain is this side. You cannot go outside the domain, outside the surfaces of this. My bad. Yeah. Okay. Let's talk about level curve, right? So if I go back to this phenomena, I told you level curve is basically where you're cutting, and also these level curve and these are contour along z-axis in the different direction. You put it over there. Give me a second. So what I'm going to do, I'm going to show you one real example of this contour and level curve. So most of us familiar with this kind of contour, right? It's basically a temperature map. Every time we watch the weather network or weather channel, whatever, you saw these kind of contour. What exactly this contour means? Let's suppose you have a big land, like let's suppose North America or just US. In United States, we have, the map is look like this. This is Florida, blah, blah, blah. This is New York, and it's like this. This is a map. And you are looking, maybe today is October 18, right? October 18 map or October 19 map, whatever temperature, you're looking at the temperature. Can you see the temperature? No, temperature is invisible. Temperature you cannot be seen, not visible. But temperature is a physical quantity. Remember, physical quantity. is a very important concept we learned in the very first few lectures, physical quantity versus two branches, scalar and vectors. So temperature is a physical quantity, yes. What kind of physical quantity? Scalar. So we only need value. We don't need direction. Temperature is a value, we only need value. So somebody saying here is temperature is 50, maybe here temperature is 80, maybe here temperature is 40. I want to visually see those temperature. Temperature cannot be seen. I want to visually see those temperatures. So what I'm going to do, I'm going to make a function temperature. Temperature equals to something x, y. T is a temperature, by the way. And you're going to be drawing a bunch of curves here. You know, it's like a rocky land, a bunch of curve and everything. But those curve is not a land. Remember, I make a bunch of curve here. These curve are not a land. This is actually temperature. And what you do then, you're taking a big kind of slice and take another slice, then take another slice, another slice, right? And taking 1, 2, 3, 4, all these have to be just passed from just taking all this cluster into that and then putting into that. So what's going to happen? You're cutting. Maybe the top one is going to cut this contour. The second one is going to contour. Some of the tip is going to be chopping by the top one. The bottom one may be cutting by this. And you're going to take all these curves and draw it. So really what this curve is telling you, you can see even here temperatures are here. You see here 60 degree, 55 degree, then 60 degree, whatever, 50 degrees, 60 degrees. Here is you see 85 degrees. But you notice one thing. I can distinguish where is hot, where is cold. I can right? I can visually see the temperature, which is not a case for me to look into that in the real sense. And that is why the contour and level curve are so useful, right? And it can be used for many different scenarios. So what we're going to do, we're going to do one example for this since we have a limited time to how we can do the contour or level curve. Let's do it. Let's take a look at another problem. Sketch and contour a map of the function. Sketch a contour map the function is giving pretty much like this. And where the map, remember I give the value z. So I'm going to say the value using the values of, we don't use z anymore, we're going to use a word called k, and I can tell you why. Maybe 4 including 4 dot. You can keep increasing. Since value of z you can write usually like z equals to function of x and y. Z only have one value for particular value of x and y. But since we have a bunch of different values, we distinguish between one value of z versus variable value of z. So we use k instead of z and putting a bunch of values, like different values, just for the sketching, the contour, right? So what I'm going to do, I'm going to go to solution here. See, solution. So I'm going to go start with k value is 0 and k means z. So I'm going to say this. 16 minus x squared minus y squared equals to 0, which is this function. So I'm going to call this whole thing called k. So I substitute here. It's going to be look like 16 minus x squared minus y squared equal to 0. And if I want to a little bit simplify further, this. Same thing if I go to k equals to 1, I'm going to say here a 1. So it's going to be 1 here this time. And if I take the square root on both sides, it's going to stay the 1. And your answer will be 16 minus x squared minus y squared equals to 1. And if I rephrase, this is going to be 15 minus equal to x squared plus y squared. Okay. Go to k equals to 2. It's going to be 16 minus x squared minus y squared equals to 2. And if you rephrase, it's going to be look like the square root on both sides, so it's going to be 12 equals to x squared plus y squared. K equals to 3 is going to be 16 minus x squared minus y squared equals to 3. And when you take the square root on both sides, it's going to be 16 minus x squared minus y squared equals to 9. And if you rephrase this one and rearrange the equation, it's going to be pretty much 7. 9 minus 16 minus 9 will be 7 equals to square plus y squared. And k equals to 4 is going to be 16 minus x squared minus y squared equal to 4. And here 16 minus x squared minus y squared equal to 16. 16 cancel. X squared plus y squared equals to 0. So really what I got, pay attention here, it is very important stuff. I got this, that, and this one. Right? Really I got 5 curve. Really I got 5 curve. And what is that? This is basically a dome shaped like a 3D sphere. Just watch what I'm doing. I start with k equals to 0. K equals to 0 means z value equals to here is z equals to 0, then z equals to 1, 2, 3, 4. So when I say 0 equals to 0, I'm going to basically cut this guy from here to there, then cutting on the back side, cutting here. And if I do vertical line test here, vertical line test, making a vertical line, this line is cutting here and here, this surface, and it does not passing. So initially it's not passing. It's not passing. It has two values, plus minus. But since I start z equals to 0, so this portion is already gone. If you pay attention, the bottom portion is already gone because of my first slice is this one. So really if I want to draw this guy here, it's going to be look like. Then you start with 0, my curve is look like this. And the bottom, very bottom curve is look like this, where the k value equal to 0. The second k value I'm going to be drawing here is going to be cutting this here. The third one I'm going to put in a k value here. Is going to be cutting from here, then there. Right, 1, 2, 3, 4. And you can see here, this is circle. This is circle. This is circle. This is circle. This is also circle. This circle has 0, radius equals to 0. This circle radius equals to maybe 7. This circle radius equals to 12. This circle radius equals to something else. This circle radius equals to something else. But if I want to draw, right? If I want to draw the contour, if I want to draw the contour, it's going to be look like this. K equals to 0 means circle with 0 radius in the center. So you're going to be drawing maybe like look like this. Then k equals to 1, right? Sorry, k equals to a little bit bigger, like a 3. So maybe it's look like this one is k equals to 3, then again bigger, then again bigger. And I can just type right here k equals to whatever, k equals to 0, k equals to 1, then k equals to 2, then k equals to 3. I probably need one more, k equals to 4, k equals to 4. So really these white color contour, these are the curves here. So you can call it this whole thing, you can call this whole thing contour, right? I can call contour. This is a contour, and every individual of these called level curve. Every individual of these called level curve. If I'm gonna give you another example, it's gonna be look like this. But what we're gonna do, we're gonna be using the calculator for that. Okay. So the example is maybe you can use the example as well. Let's take a look another problem. The example is here is sketch the contour map of the function. It's called a contour map of a function. It looks like it's a map. And the function is this. And using the values, k equals to 0, 1, 2, 3, 4, dot, dot, dot. Right? Maybe you can say just you don't want to be doing all because they are very close. Maybe just make it a little bit far away. So 0, 4, jumping into the value. So you want a little bit more gap between the slices. Right? If the slices are very close to each other, like you making curve like 1, another 1, another 1, it doesn't make any sense, right? Right? Like just like you are talking about, hey, what is the temperature at my house? 70. And you go to the neighbor, says, hey, what is your temperature at your house? It's pretty much, he's gonna feel the same temperature like you do because it's like pretty much doesn't change much. Yeah, but if you call your friends who living 500 miles away from you, then they have a different temperature, right? So that's why we're making these lines a little bit far away. Otherwise, these lines have really doesn't make any sense. So what I'm going to do, I'm going to using the calculator rather than I'm using my hand calculation. I'm going to be using a simulator to do this, and I'm going to save some time definitely. So 2x squared plus y squared. Let's do it. All right, that is my function. I'm going to write here 2x squared plus y squared. So I'm going to just type here 2, and that is my function. Look like, you see, this is my function. Look like pretty much a parabola or paraboloid in 3D. And I want to cut this thing into different locations. So I'm going to cut here, 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 here based on the z value. So this is my k value. So what I'm going to do, I'm going to starting with different values of k. Watch. K equals to 0. My question say k equals to 0. So I'm going to come more. See, at 0 is touching the plane. Let's start. You can add different values. If you want to add different values, you can further go, and then this is your contour curve at different values of k. You can tell by looking temperature. These are the values. You can actually tell the height by using these curves. You can tell the height of these curves, and this is kind of a visual representation of something that you cannot see by your eyes. Like few things in your life you cannot see by eyes, and this is a visual representation of those things. Thank you for watching Knowledge Academy. Please subscribe my channel.